Etabs offers a powerful utility named Section Designer for the creation of any type of frame or wall pier section. These sections may be used for both analysis and design within Etabs. The Section Designer utility may be accessed through the Design Shear Wall Design menu for piers, or through the Define menu for frame objects. For frame sections, it is found under Add SD. The base material may consist of any previously defined material property, which identifies the type of design post-processors that will be available, as well as how the section properties will be reported. If we select concrete, we can then have the option of either no design or concrete column for the design type. When Section Designer is activated, we have templates for structural shapes, solid shapes, and polygons, which may be combined into a single section for Etabs. The structural sections typically associated with steel shapes include wide flanges, channels, and others. A click on the grid locates the center of the shape, and a right click on the shape brings up the Properties box, where the material, size, and location may all be edited. There are also several solid shape templates, typically used with concrete sections. Again, a click on the grid locates the center, and a right click on the shape brings up the Property box, whereby we can alter the material, location, size, and reinforcing if concrete. Last is the Draw Polygon Shape command, where the user can draw a very arbitrary polygon. Again, this would typically be used for concrete sections. The Shape Properties box allows you to specify the material, and if concrete, the reinforcing. The Reshaper tool allows you to change the geometry of the poly shape by either right-clicking on a corner and typing in the coordinates, or simply by dragging a corner. You may also use the Reshaper command to move the shapes. At this point, it should be noted that all three of the drawn shapes constitute a single section, and though one of the shapes is steel, the Section Designer utility will calculate properties for Etabs based on the equivalent base material of concrete. It should also be noted that only the member 2-3 axes have meaning for Etabs, as the XY axes shown are local references only. For this example, we will create a rectangular beam section 12 inches wide by 16 inches deep. Reinforcing will be 2 number 8 bars at the top and 2 rows of 3 number 6 bars at the bottom. Cover will typically be 1.5 inches, except at the top where cover over the bars will be 1 inch. To draw the beam section, we will use the solid rectangle shape. A right click brings up the Properties Edit box, where we can change the height to 16 inches, the width to 12 inches, and ask for reinforcing. Enlarge the view to make it easier to work with, and right-click on one of the edge bars. Set the bar cover to 1.5 inches and apply to all of the edges. Note that corner bars are located by the 2 adjacent edge covers. Right-click on the top edge bar and set the bar size to none, with a cover of 1 inch. Apply these changes to only this edge. Next, right-click on one of the right edge bars and set the bar size to none. Repeat this step on the left edge bars. Right-click on one of the top corner bars and set the bar size to number 8 and apply to all corners. Right-click on the bottom edge bar and set the bar size to number 6 with a spacing of 4.2 inches. Next, right-click on the bottom corner bars and change their size to number 6. The section is complete except for the needed second row of reinforcing in the bottom. This is done with the Draw Reinforcing Shape command, where we can add reinforcing bars as single bars, a line of bars, a rectangular pattern, or circular pattern. For this case, we will add a linear pattern, clicking to start and end the line. A right-click on this bar brings up the Properties Edit box, where we can type in the exact coordinates of the endpoints of the line. Change the bar size and spacing to match the row below, and ask that end bars be included. The section is now complete. Under the Display menu, we can ask for the calculated section properties, including the area, moments of inertia, and all of the other generated properties. We can also view the interaction surface, including a 3D view that we can spin around. We can also toggle through the various curves at different angle settings. Section Designer also lets you view the moment curvature curve for reinforced concrete sections. You may pass the cursor over the curve for specific values. The next step is to send the section information to Etabs by clicking on the Done button, and then OK to add the section to the frame sections list. Next, we will assign this newly defined frame section to the beams in our model. We will replace the conc beam property with the new SD property. As previously stated, we may also create or modify wall or pier objects in Section Designer. However, prior to doing this, the wall objects must be assigned pier labels. Assign this wall the label Wall Pier. Now we can go to Design, Shear Wall Design, Define General Pier Sections to access Section Designer. The base material will be concrete, and we will start from the existing wall pier, although we could create a completely new section as well. The existing wall pier section is brought into Section Designer. The wall is a poly shape, so we can use the Reshaper tool just like we did for the frame objects to stretch and move the shape. A right-click on the bars brings up the Reinforcing Edit box, where we can alter the size and spacing. A click on the Done button brings us back to Etabs. Now we select the wall pier to assign the section that we just created. This is done through the Design, Shear Wall Design, Assign Pier Section Type. We'll use the General Reinforcing section, PSEC, at both the top and bottom locations. We will ask for the reinforcement to be checked. We are now ready to run the analysis. Once the analysis is complete, we can start the design for either the concrete frames or shear walls. In this case, we will do the check for the shear wall to verify the reinforcing previously defined is adequate. A right-click on the section brings up the peer flexural check, where we can verify the adequacy of the reinforcing, as well as confirm the section used. This concludes this example.